Okay, lower bound and upper bound. Remember, start with 9 seconds to the nearest second. If you're going with 9, what are the values that are above 9 to the nearest second? 10, what's the value? So halfway between 8 and 9, you have 8.5. Halfway between 9 and 10, you have 9.5. That's your first set of answers. If you have 100 centimeters to the nearest 100, what are the next values up and down to the nearest 100? Up from 100 is 200, down from 100 is 0. So again, what's halfway between these two intervals? The lower bound will be 50, the upper bound will be 150. Those are the lowest and highest numbers that round to 100. If you have an issue with the 0.5 thing, what I would say is that the decision to round the number which is exactly halfway between two, whatever your interval is to the nearest second, so halfway between 9 and 10, the decision to round 9.5 up or down is arbitrary. By convention, we say round 9.5 up to 10. But in principle, it's exactly halfway between 9 and 10, so why should you round it up? That's a decision which is not as clear-cut as perhaps has been stated to you in the past. But basically 9.5 is exactly halfway, so you can round up, you can round down, but it is the bound, and the decision to round up or down is an arbitrary one. And so don't be writing 8.4999 or 9.499 in this case. Just go for the halfway point between two values, and that is the highest value, which could round down to 9, and the same with 150. For the nth term of the sequences, right, it's going up in 4s, so it's based on the 4 times table. The 4 times table, 4n goes 4, 8, 12, 16. So what have you added to the 4 times table to get this? 4. So it's 4n plus 4. This one's going down in 3, so it's the minus 0.3 times table, which starts at minus 0.3, then minus 0.6, minus 0.9. And what have you added to the minus 0.3 times table to get these numbers? You've added 2.2. Quadratic is slightly more tricky, but most of you remembered that you look at the differences, which are going 9, 15, 21. They're going up in 6s. A few people put 6n squared. Remember, this is going to be based on the number of n squareds is half this second of difference, the difference between the differences. So if the second difference is 6, it's going to be based on 3n squared. And this sequence is quite an easy one. It happens to be 3 times n squared. N squared, remember, goes 1 squared, 2 squared, 3 squared, 4 squared. And if you take those numbers and triple them, you get this sequence. So if that's n squared, this is 3 times n squared. Simplifying your indices. When you have the same base, x here, you add the powers when you multiply them. So this would be x times 28. If you look at this one, you've got x to the 17 divided by x to the 2, so you subtract the powers, you get x to the 15. And 20 divided by 5, you know what that is. That's your answer. This one is the one that people get wrong most often. You know that x to the 2 to the 3, as opposed to x squared times x cubed, which gives you x to the 5. X squared cubed is x squared times x squared times x squared. So that means it's x to the 6. But don't forget you have to do 2 cubed as well. A lot of people would write 2 at the front of their answer or 6 at the front of their answer. 2 cubed is 8. If you want me to justify the final answer, 2x squared cubed is 2x squared times 2x squared times 2x squared. That's 2 times 2 times 2, or 2 cubed, it's 8. What's x squared times x squared times x squared? X to the 6.